A pulley on a frictionless axle has the shape of a uniform solid disk of mass 2.5 kilograms and radius 20 centimeters. A 1.5 kg stone is attached to a very light wire that is wrapped around the rim of the pulley, and the system is released from rest. How far must the stone fall so that the pulley has 4.5 joules of kinetic energy? B. What percentage of the total kinetic energy does the pulley have? This problem is based on the law of conservation of energy. Here, the mass of the pulley is given as 2.5 kilograms, and the radius of the pulley is given as 20 centimeters. We have to convert the centimeters into meters. Therefore, the radius of the pulley is 0.2 meters. The next mass of the stone is 1.5 kilograms, which is hanging from the pulley. Now, this is the system, and the mass is released from the rest. Am I right? The system is released from the rest. A 1.5 kg stone is attached to a very light wire that is wrapped around the rim of the pulley, and the system is released from the rest. That means we need not consider the mass of the string, and we have to consider only the mass of the stone, and for other purposes we have to consider the mass of the pulley. And here in this data they gave the kinetic energy of the pulley as 4.5 joules. How to find the kinetic energy of the pulley? Because the pulley is rotating, so it has the rotational energy. Am I right? So kinetic energy of the pulley is rotational. Therefore, rotational kinetic energy is half I omega square, which is equal to 4.5 joules given to us. Therefore, 4.5 joules is equal to half into I. We have to calculate the moment of inertia. I is equal to half mr square. Therefore, half into mass is 2.5 kilograms, pulley mass. And then the radius is 0.2 meters. So 0.2 square gives the moment of inertia of the pulley as 0.05 kilogram meter square. Now, angular velocity omega is equal to V by R. Therefore, omega square is equal to V by R square. Therefore, V by 0.2 square. Now we substitute that here. Therefore, 4.5 is equal to half 0.05 into V by 0.2 square. Now on solving, we get V is equal to 2.68 meters per second. Now, initial energy is equal to final energy. Okay. So what is the initial energy? Initially, the stone is at the top, here. This is the point where the stone will be. Now, after releasing, it comes down to this point. Okay. So initial energy is purely potential. Therefore, mgh, that is equal to total kinetic energy. Kinetic energy is translational and rotational. Okay. So K translational is half mv square. Therefore, here for the stone, half into mass 1.5 kilograms, and then velocity we found out as 2.68 square. Therefore, translational kinetic energy is 5.4 joules. And then rotational kinetic energy is already given to us, that is 4.5. Therefore, H is equal to total energy divided by mg. Therefore, 4.5 plus 5.4 divided by 1.5 into 9.8 gives the how much distance the stone will fall. Okay, so here it falls 0.673 meters. The stone falls 0.673 meters. Second bit. What percent of the total kinetic energy does the pulley have? So we have to calculate the percentage. Pulley kinetic energy is 4.5 and total is 4.5 plus 5.4 is equal to 9.9. Here is the 4.5 given in that problem itself. And we found out the translational kinetic energy of the stone as 5.4. The total is 9.9. So 4.5 over 9.9 is equal to from 0.455. And then percentage wise, it is 45.5. Okay, this is the answer for this one. First, we have to find out the rotational kinetic energy. And that rotational kinetic energy, after finding the rotational kinetic energy of the pulley is given to you. So you have to find out the translational kinetic energy of the stone, and then you have to add and then find out the distance fallen by the stone. That is the problem. Hope this helps. Thank you. Bye-bye.